At our continental scale from last Friday, right, Pete?
Yes, it starts last Friday and goes through today.
And these are 15-minute images?
10.
Okay, 10-minute images. So you might remember our really nice cyclone from last week. And the tropics have been very active, both in the sort of high latitude tropics as well as the ITCZ, as Greg Tripoli was just pointing out. More often than not, you don't see it lit up quite like this in the far eastern Pacific basin and south of the isthmus. But it's really been lit up like that for a large part of this month, and now we're on the 20th day of September. So you can see Umberto get organized in this movie and then churn up the coast. I think there was one death reported on a smaller island near Bermuda, but not in Bermuda itself, although Bermuda experienced hurricane force winds. And then the amazing slow burn disaster going on in the Texas Gulf Coast associated with Imelda, which never got anything more than tropical storm status. And look at the scale of it. It's just a small scale disturbance. You'll also notice when we look at a couple of other, maybe closer up, basin-wide images instead of the whole hemisphere, that Imelda seems to, and at high resolution in time, Imelda seems to have a substantial pulsing to the intensity, at least of the cold cloud tops, which presumably reflects pulsing of the intensity of the convection. And there are places in the Houston metro area and other spots that have had over 30 inches of rain. So it's starting to sound like a repeat of Hurricane Harvey, but it was never anything like a hurricane. So there was no tidal flooding, nothing like that, like on Galveston Island or any of that.
Harvey wasn't all that impressive most of the time either.
Wasn't there a period of 75 mile per hour sustained winds though along the coast?
There was a period, but during much rain, it wasn't very.
Yeah, I do remember that. That's true. That's a good clarification. That the rain event of Harvey far exceeded in profile the wind event. No doubt about that. But there were places that felt a little bit of both when it first came on. Mm-hmm. Sure, that's not true with Imelda. And so this thing is, to me, a real mystery. I admit I'm not an expert and don't really have a great interest in the tropical disturbances as much as the extratropical disturbances. But this thing just, even its appearance on the satellite movie is confounding to me. I don't think I understand anything about what's really happening down there. And sorry,
can I show you this picture of what's going on right now?
Well, yeah. How can we show it here?
Pete can go to that webpage, the Kaifield page.
Then you got to talk about it because I don't want to be the translator. You know what you're talking about. I don't.
It also went from no advisory to landfall and tropical storm within 2 hours.
Is that right?
Yeah, the advisories went from like nothing at 10 a.m. to landfall.
Well, the movie that Pete was showing when I first came downstairs is a little bit higher resolution in time and smaller in scale. And you could see that makes sense looking at that satellite movie. There was nothing put together, and then suddenly it was there.
Advisories are kind of almost comical. It's just like
just do the first frame.
Amazing.
All right, this is what I think is going on with the whole ITCZ and everything. See this blue area here? This is unusual. This is not usually the case. This is the chi field, which is velocity potential. Del squared chi equals the divergence. And so when this is blue, that means that field is divergent. This is up at about 356 K, about 14.5 kilometers above the ground. So this is the outflow level of convection. The outflow level is dominated by this large region of convergence or divergence here. And there's normally a large region of divergence in the West Pacific. And this kind of red area, which would be convergence and suppresses things, is usually starts somewhere around here and goes almost all the way across, except for occasional movements over this way. But to have this blue area here covering this entire region near us is very unusual. This general region of divergence over here and convergence on the other side of the globe is called the Walker circulation, for those of you who know that. And so Walker circulation is usually a one-cell circulation that dominates the tropics, divergence in the Western Pacific, upward motion, and convergence more in the Atlantic, downward motion. And then during La Nina years, when it's enhanced, quite often the divergence and convergence is so strong that things are very, very suppressed out here. It's hard to get a hurricane going. This is the way it was back in earlier August. And since August, this has started to shift and split up. I don't recall I've ever seen it almost bimodal like this. I mean, this is not so much of a propagating circulation. Now, sometimes you'll see Kelvin waves break off and come across. This is almost different. I don't know exactly what's going on with this, but I think this divergence loft explains why this thing just keeps going over here. And,
So it's like a standing wave number 2 in a Walker circulation. It
yeah,
should be
it's
wave
almost
number
like we're pretending to be the West Pacific.
It's really weird. How does the Walker circulation admit bifurcation, getting split in half into 2 separate cells?
It's strange. I don't know how that, I really don't. I mean, this is where the ITCZ in here is all lit up across
Yeah,
here.
yeah.
But it's,
Yeah.
that's why it's lit up.
So
Normally lit up in the West Pacific like that. Now it's over here. The water's a little warmer, but you know, in only New Year's it never gets like this.
yeah.
So I don't know. But I think this is, when I see this sort of thing, that's what I look for. When I see kind of the blue areas or some blue get into the East Pacific and Atlantic, that's when you look for the hurricanes to develop. But just having this thing come over here, it's been here, it's moving a little bit, but off and on for the past month almost, it seems. It's been hanging around.
And the label says it's at 356 Kelvin, so it's right at the tropical tropopause, effectively, right? Okay.
It's at the outflow level for
Yeah, okay.
convection.
Wow, that's really wild. I wish I knew more about the basic CLIMO, but you explained it nicely, that it's usually just 2 cells. The Pacific is the.
Well, usually
West Pacific
one cell.
updraft.
It's
I mean,
usually-
one cell, yeah, that's
yeah,
what I
one
meant to
cell.
say. And so the West Pacific is the fountain, and then the subsidence is over the western US and Central America.
Right.
Yeah.
It's split into 2 now, so for whatever reason.
That's really wild. So here's the close-up, thank you, Greg. Here's the close-up, sort of Gulf of Mexico basin and southeast Atlantic, or southwest Atlantic, that you can see what's going on. This is the collection of activity, the thunderstorms that will turn into Umberto, and then it takes its sweet time, but here's what we're going to see kind of be melded together. Here's the Texas Gulf Coast, here's Florida. So those boundaries are a little bit hard to see. The states are in red and the continent's in green. So you gotta, once you find it, stay on it with your eyes, otherwise you can lose it. So here's Umberto getting well organized. We've had near misses along the space coast of Florida all summer long, and this was another one. One of the things that was evident about Umberto was the extraordinary shear on the poleward side, and you can see the clouds just being carried away abruptly. Here's Imelda. This must be, Kelton, what you're talking about. Who would have said this is going to be something to contend with, and then suddenly it's on the coast and it's raining at 6 inches an hour or something, and the thing just exploded in situ. It almost reminds me, Greg, of the time you got your new car, but on a higher profile.
Yeah.
That? We had 4 inches of rain that developed under a
Yeah.
thunder shower in 1 hour. That was incredible. So yeah, I got to tell you, Greg he had just gotten a brand new Prius with cloth seats. So, and the insurance kicked in. It was like a week old, and the thing was flooded down in lot 71 or whatever it is, close to you. And he comes in the next day or a week later, and he says, "I just got a brand new car replaced, leather seats. The whole thing cost me $200." So it's pretty good. So I don't know what the Walker circulation was doing that day, but it worked for you.
I was in Boulder on vacation. We were hiking up behind NCAR and out of cell service.
Yeah.
And it all happened while I was out of cell service. I came back down and I got like 50 voicemails. I'm like, what's going on?
It was unbelievable. I walked across the street to get something to eat, and I checked the radar when I left. I said, "Oh, there's nothing going on. I'll be able to get back and forth." I knew it was going to be a day where we had a threat in the afternoon. And while I'm over there is when it was raining, and the waves from cars driving by on University were lapping up against the stairs of the old cousin sub. I had to stay there. We were an island. It was unbelievable. Okay, that's a digression.
When was
So
that?
that was
2007, maybe?
2007 or 8, yeah, 2007 it must have been. Yeah. It was incredible. 4.3 inches of rain we had that afternoon, and it was all within two and a half hours. Okay, so I was struck by the pulsating nature of the cold tops of the clouds when Imelda gets on the shore, southeast coast of Texas. I just can't really even understand what's going on with that. So I think there's going to be abundant number of case studies to try and understand what really was going on with this. And then Kelton brings in the new ob that I didn't know about how the warnings were just put up 2 hours before the thing actually took shape. I mean, that testifies to a lack of thorough understanding of what was going on with this storm from more than one perspective. And look, there's nothing there, and then boom, and then watch. They'll decay away. Doesn't look like anything particularly significant there, though there's a circulation for sure. And then another explosion of convection. It's It's very exciting.
That's not diurnal, huh?
No, because this is too short a time. This is, every tick there is 1 hour. So we're not getting close to even a 6-hour period in that. And that's the first thing I thought too, is what prompted my question.
I'll go back and extend this loop. This one I made on, I think Wednesday or Thursday.
You see that tropical squall line moving across the Gulf?
Yeah, this one here. And then look at the
First part,
front,
it was moving,
and then the front edge of it just races at one.
yeah.
Maybe we've passed that point. I guess maybe we have.
I know there was like an upper level low that was helping, or that was causing some shear on Umberto when I was looking at that.
Mm-hmm.
So there might have been an upper level signal that was there for a lot longer that then somehow kind of corrected.
Well, even, along those lines, even in the beginning, and this is we're now near the end of this loop, but at the beginning, if you pay attention instead to just cirrus debris that's moving across like Arkansas and Tennessee, that's moving at a pretty good clip from west to east. And so one gets the impression that you're never too far to the south of what's probably substantial vertical shear.
But look at that outflow burst out of that thing,
Out of which one?
out of the one over Texas when that thing blooms. I mean, you could just see that outflow. Watch it, just look at that. Boom.
Yeah. There's a lot of
I mean,
that
that's
being pushed
way
aside.
too easy to do.
Yeah. How does it
For
do
such,
it?
that's because of that Walker or whatever that circulation is.
Yeah.
200 millibars is doing that.
It gets an assist for sure by something on a larger scale. It's got to.
There's nothing to stop it.
Okay, so thanks, Pete, for these as usual. Some weeks they're just really well worth the time invested, other times not so much. Today was a great example of that they are.
The only other one I was gonna show was. hey, we
Oh,
got
yeah, the fog.
The 1 minute mesoscale wave fog is pretty epic.
Did we decide it was Wednesday or it's
It's
Tuesday?
the 16th, so.
Monday. We had fog on Monday. So look at the beautiful river valley fog you can see along the Wisconsin River and tributaries, and then you can see things on the lake. It's a little bit hard to tell what's fog and just what's cloud, but there was fog banks coming in along the lake shore during the day. And of course, Sheboygan is well known to be a foggy spot on such days, and there've been multiple car pileups in the past there, and both in the winter and the late fall. I don't think anything such as that happened this time, but that doesn't mean you should be careful. I remember knowing this was coming on Sunday night, I told my son, drive carefully. He doesn't drive over this way, but just, you get fog and it invades those little river valleys, even little creek valleys can give you some trouble. And there was an accident, was it last fall on 151 south toward Verona?
Yeah.
Where the sun was coming off the fog bank at
Right
the
down
wrong
the
angle.
valley, yeah.
Yep, and 150 cars piled up, so it can happen in the most innocuous seeming circumstances. So that's kind of a nice movie too. So let's take a look now at our continental scale satellite movie for the current time. And Pete goes right to the black one. Thank you.
This is visible.
I like it. So here's the visible, and you can see the tropics, individual features within the tropics really in the shorter time frame are still lit up. So we've got, this is Hurricane Jerry, I think. There's an extratropical disturbance kind of melded out of Dorian, whatever's left of Dorian, or other disturbances.
Umberto,
No, not
right?
Dorian. Umberto, yeah, sorry, I had the wrong one in mind. And Umberto. And then Kiko is well to the west, now a tropical storm, but I think it's a tropical storm. It had been a hurricane most of the week. And then Lorena is going up into the Baja California, and this one is Mario, right? Is that right? Okay. And so there's a whole collection of different storms. There's active convection over parts of Western South America, the Western Basin, that's over Colombia. So it's just wild. It's really wild going on today. The continental United States, a little less impressive, although here's the remnants of Imelda. And so we'll see in the radar in a minute whether or not this is heavy rain visiting southeast Oklahoma and southwest Arkansas. I think it is. And then you're running into terrain too. The Ouachita Mountains are right in this location. So that's a threat. If rain is heavy, you get local flash flooding in those places. So one has to be concerned about that. And you can see the widespread low stratus and maybe even fog in the northern part of our state, in Wisconsin, parts of Minnesota. Nothing obviously well organized off the coast, and we'll try and look at the west coast in just a minute. So broadly speaking, this would be the kind of day that the students in 452 often call is rather boring in the mid-latitudes over our location. I think I'd probably agree with that. It's not particularly exciting, no well organized weather systems, no interesting structures to see, at least not obviously from looking at the satellite. So let's follow this up by taking a look at the radar over the continental U.S. And this is a little less boring. I think it's raining in quite a number of places and for a variety of different reasons. Here's what's left of Imelda, and it does look like moderate precipitation down in that sort of mountainous region of the western part of Arkansas and the southern part of Oklahoma. So the mountains are a little further to the north. But that's a concern, I imagine, for some locales in this part of the country. Then some pretty intense convective activity right along the Minnesota border with Saskatchewan, and then in the western Dakotas and racing poleward. You'll see why when we look at the upper level charts. There's a really strong flow, more or less parallel to the high terrain, indicated, I guess, a little bit by a tendency to see something like a cyclonic circulation over the Great Lake, the Great Salt Lake, and that indicates the presence of a pretty substantial upper trough that will undergo quite a radical evolution over the next couple of days and sort of remove itself as a threat for any more organized weather by doing that, it looks like. So those are some of the things that we might pay attention to when we go to the upper level charts. And we'll start now with the 500 millibomb chart of what we affectionately call the super peats because they're so big. They're just fantastic maps. So let's see. Yeah, okay. So this is this morning at 7 a.m. So here are the broad scale features at 500 millibombs. Here's the broad trough complex that has associated with it what's left of Umberto and a broad mid-latitude trough all by itself. Big anticyclone sitting over the southeast U.S. and elements of other convective activity to the south, put a little dents in that ridge. Here's the upper trough of interest over the western United States. And you can see the center of that circulation is just about over the Great Salt Lake. It's actually maybe on the border of Nevada and Utah at that latitude. So that's about where the center of the circulation is. And you can see the elements in the radar that we're paying attention to that. This is a pretty substantial region of local curvature. And so downstream of it in western Colorado, let's say, maybe south central Wyoming, one might expect substantial upper divergence in the production of maybe some drops in sea level pressure or adjusted sea level pressure in this location. Yesterday, the upper baroclinicity ringing this trough was a little more intense. Right here is a preservation of what it looked like along much of the whole periphery. It's kind of getting eroded a little bit now on the edges, but this was a pretty decent, but not strong, baroclinic zone. And it had been fashioned, it looked like, by the distribution of vertical motion in and around the trough. The flow is quite wavy upstream of this feature. This is maybe the leading, maybe the ridge axis over the U.S. is broader, but maybe the leading feature of a bunch of waves in the mid-latitudes that will manifest themselves in a variety of ways in different levels too, not only today, but in the future. So it's a pretty wavy period across North America and adjacent waters, but not a very cold one. Temperatures continentally at 500 millibars are almost uniformly above 10 degrees in the eastern two-thirds, minus 10 degrees in the eastern two-thirds of the United States. A few local spots are chillier than that. Of course, in the middle of the trough, you're about minus 21 to the west of the Great Salt Lake, minus 20 at Boise. So that's not very cold, but that's as cold as it gets with the current situation of the sun positively tilted at prior times. It's becoming less and less so. And you have to take my word for it, or we could go through the movies. I don't think that because there's other things to talk about. But it's getting less and less positively tilted. And sometimes a harbinger for interesting weather downstream of the trough axis. It doesn't seem like that's the case this time. And I'm not sure I know exactly why that's true. I will point out, though, if we go to 300 millibars at the same time, that the polar jet is confined to very high latitude in this quadrant of the northern hemisphere, way up south of Greenland, and then racing south of the Aleutian chain. And we'll see this is part of a very extended jet at high latitude over the Pacific Basin, which will have an influence on North America very soon. But in and around the upper trough here, the highest wind speed that's reported doesn't get to 100 knots, and the analysis even stays away from that, puts it to 99. And the highest wind is at Salt Lake City, which is 90 knots. At 300 millibars, a fairly weak flow associated with this upper trough. A day ago, the strongest winds were on the upstream side of the trough, which tends often to lower the geopotential heights in the middle a little bit. But once it races around the base of the trough and it emerges on the eastern side, the heights can fill in a little bit and the thing can weaken. What's interesting is that this thing is not isolated from tropical influence. So let's go to 200 millibars to be sure we get this thing. And that is, look at the subtropical jet. Maybe 250 is better, actually. I looked at both this morning.
Wait a minute.
This is
wait a minute,
250.
wait a minute, wait a
Oh,
minute.
yeah, let's go to 200.
Look at that 200 millibar.
Yeah, so the subtropical jet is more
Where's the
substantial.
outflow from this storm in Texas right now?
There's one?
This is today.
Yeah.
Where's
7 a.m. this
the
morning.
outflow gone from the storm in Texas?
Storm in Texas is on its deathbed.
But you don't see any, jet streak resulting from that.
No, that's true. There was maybe because there's a pre-existing ridge and it was just easy to get it out of there and not focus.
Doesn't that strike you as pretty unusual when you have a tropical storm that far poleward and there's no jet streak produced in the extratropics?
I think that it has to be in a region where you've got a substantial background gradient of the PV. If you're in a flabby ridge axis, that's probably the worst
No,
place to do it.
Well, if, for no other reason, if I put a tropical low there, I would expect something to go forward because that's where usually the best inertial stability is to throw the jet because of the baroclinicity to the north and the wind shear is anticyclonic. But it's throwing its outflow mostly to the south.
Well, it looked to me like from the satellite picture that it was going almost symmetrically.
Almost symmetrically, but
But I would say that maybe the symmetry is a function of the lack of resistance anywhere around it.
right. But it looked like it was sending a lot to the south, which is unusual at that ledge. I think
Yeah, okay.
I think that is a consequence of this wave or whatever that thing is at the upper levels that's coming through. It's very different from a normal tropical storm and what you're seeing and how it's interacting with the extratropics. It's not interacting with the extratropics.
Yeah, I think, I didn't think about it from that point of view, of course, but upon looking at the immediate extratropical environment into which the air might be ejected, this is not going to be a favorable environment.
This thing is up along the North Gulf Coast. I mean, that's really unusual. I mean, I don't know if I've ever seen that before. There's so much into the tropics, and the tropics are just giving it plenty of support, which is unusual because of that big blue area. And so something is different going on right now.
Okay.
I don't know if it's unprecedented, but it's very unusual.
So I'm interested in the stronger subtropical jet that one sees at 200 millibars interacting with, in some way, shape, or form, the extratropical trough axis. This is a really good place if you want to progressively tilt this thing to be less and less positively tilted to put a jet. So somehow, in ways that I'm not going to be able to articulate and I don't understand yet, somehow the interaction between the pre-existing polar trough and the subtropical jet is actually working to change the orientation of that trough and potentially change its impact downstream over central North America. And that's not uncommon, but it's just interesting to note on an otherwise less than exciting day, weather-wise. I think I'd like to show Pete, and this blends now into the forecast. Could we take a look at the 300 millibar hemispheric projection from the GFS? Well, I don't know if the 12 hour is all in yet, but let's see if it is. Let's take a couple of times. 300 millibars. So let's start at 12 hours into the forecast. No, I'm sorry. This is 12Z, so let's start at 0 so that we get the analysis. So this is the analysis this morning of 300 millibar jet stream and geopotential heights. And so here's North America, continental United States, just for getting an idea where you are. So right off the north coast of Japan is where the jet really picks up over the Pacific, and then it's more or less a zonally elongated jet all the way to the longitude of Dutch Harbor, Alaska, which is well toward the continent, not at the end of the Aleutian chain. That's an extraordinarily lengthy jet. It doesn't seem to have anything obvious on its tropical side that is influencing it, and very little on its polar side that's influencing it. A little bit of a trough here off of the Kamchatka Peninsula, maybe helping to enhance the wind speeds there. There's an interactive relationship there. But this is a really long jet feature. They don't last this way in the mid-latitude westerners. It'll break up. And so, and it's already a wavy downstream, which we mentioned already about the flow over North America. It's extremely wavy compared to this rigorously zonal flow over the Pacific Basin. let's step forward here through, every 12 hours or so. Or maybe we'll just run the movie and kind of step through the movie. Because that is interesting. Okay, let's just do some stepping through this then. And just watch what happens to this specific jet, especially what happens on the West Coast. Can you do it with the
Yeah.
forward things? Because then you can see the whole thing at once. Yeah, that's great. So let's keep going. So a little bit of a trough develops along this jet. That puts a bend in the jet feature as we move towards Saturday night. Look at how it starts to get ridgy. And here we are on the west coast of the United States. That's the Washington, Oregon coast, right about there. And so by the time we get to Tuesday, there's a substantial ridginess that's beginning to develop over the western United States. It's not at its full glory yet. It's going to come on. This will be a strong zonal jet coming on, crashing into the Pacific coast of Canada on Tuesday. Look at that. Unbelievable. Looks like the October 2010 event, but a little too far north comparatively. And then I think it's the next wave that's going to really build a ridge by mid next week on the west coast. Yeah, here it comes. Here it is. There's a tremendous ridge being built over the west coast. I guess it's at the end of that jet stream. And then a deep trough over the western states by the time we get to next weekend. That doesn't change things for us very much because we stay in the southwesterly flow. But over the western states, especially the northwest states, it gets considerably cooler than it had been. And that's the primary wave feature in the hemisphere by the time we're done. Is this one giant wave that stretches all the way from the Dateline to Hudson Bay and has a fairly high amplitude. So it's quite impressive. The jet, you'll notice the wind speed maximum has kind of disappeared in terms of the intensity, but it's all been manifest in the production of this grand wave. So if we can run the whole movie forward, Pete. So there's a tendency for these things to break up. They don't stay lengthy, and then big waves can develop at the end of one of these episodes. There's a period here also that tells a lot. There's the northern border with Canada. Look at how the jet segment at the first part comes right across the border. That means that it doesn't get cold here yet. We're just not going to get cold until and unless we get some troughiness over the central part of the U.S. And so this goes all the way out to I think the end of the month.
I think it's an 8-day.
Let's see, when did that end? Yeah, all the way to the next Saturday, the 28th. It's not going to really change much here in terms of temperature. That's the long-term forecast. And most of the time, that's because we have zonal flow that makes us warmer than normal over the Great Lakes states. And then late in the period, when the deep trough develops off the coast, on the west coast, we just get into southwesterly flow from a dry, hot, Four Corners, Mexican Plateau region. And it just doesn't get cold. So that's the quick overview of what I think is going to happen in the week-long period. But let's go back now to forecast for the weekend because we have some interesting things going on just next door tomorrow. I think it was a couple of weeks ago I said forecasts in the low 60s or 70s, and it turned out the Badgers won 61-0. Today I'd say, so I was right, the forecast was right. Today I'd say lows will be near zero and highs will be in the mid-teens. And so the lows will be the Michigan score and the highs will be the Badger score. I'm thinking it's going to be a task for the Wolverines to score any points. And I have a feeling also that the Badgers will, being at home as they are, enjoying home cooking, come up with 17 or so points. So they'll win 17-3 or something like that. I think that's the way it's going to go. And that'll be really nice because it'll switch the ratings, which are ridiculous, on their head. Michigan gets rated in the top 10 just because they're Michigan, not because they have any talent. And so it's going to be. Here's the forecast for right about now. You'll notice as we go forward, it'll be good to keep looking at the same chart for 500 millibar vorticity and geopotential. This upper trough, which looked fairly impressive in both fields yesterday, less impressive this morning, is going to continuously look less and less impressive as an upper feature. And then there's the conglomerative structure with Umberto to the south and some other feature to the north in a broad upper trough. Okay, so and then several different smaller scale features upstream over the Pacific in a fairly strong zonal jet that we just saw racing south of the Aleutians. So with the approach of an upper trough, of course, especially if there's ridginess downstream, there isn't so much here. one expects upper divergence downstream of the upper trough axis. So there's probably going to be something trying to get itself organized on western Nebraska and Wyoming. So I'm just going to put my pointer here, Pete. Let's just take a look at the sea level pressure forecast in that same location. And it's about 1,003 millibar low. So it's right where you might expect it to be. No expectation of how strong it might be, but that's the right location, down in the upper trough. But it's very weak, and it doesn't seem to be the governor of all of this widespread precipitation. That instead seems to be just a function of the ingestion of high water vapor content air, warm air, poorly stratified, and daytime heatings enough to kick off showers. I suspect this is probably widespread, not well organized convective activity that's reflected in the precipitation forecast. Okay, let's go ahead about 12 hours or so. So that by midnight tonight, look at how much worse off that upper trough seems to be. It's not, the curvature is very much more localized because the flow is very straight for a long stretch until you get to southern Hudson Bay. It's not very intense. We're not going to go 300 millibars. One gets the impression there is a local wind speed maximum, maybe right about the same location as the curvature, but it's not really a very strong feature. So I'd expect that whatever's trying to develop has moved a little bit further to the north, maybe here in western South Dakota. So let's see what it looks like at sea level in the forecast. Yeah, about 1,000 millibars, just about where it should be. So we've deepened by about 3 millibars. We're not really getting any benefit of the high terrain in the west because the flow is more or less parallel to much of the high terrain. So there's no lee side enhancement of the cyclogenesis. This is a really weak cyclogenetic feature. It's putting out some reasonably strong precipitation to the north of it, along the Minnesota, North Dakota, and then into Canada, the borders there. And so fairly substantial precipitation, 1/2 inch or more in some locations, looks like, is forecasted through about midnight tonight. So let's go a little bit further ahead, Pete. Let's go to 12 hours beyond that. So we'll go to, I guess that would be 30 hours, right? So this will be about the time the game starts. And we're over here in Madison. The upper trough is looking not so well organized, although there are local spots where there's pretty decent upper curvature maximum. So there's vorticity maximum. I might expect that the maximum development, if there's anything going on, is just to the southeast of Lake Winnipeg. So right about there. Let's see what it looks like at sea level in the forecast. That's about right, 997 millibars. So there's more development going on. Very slow but systematic as it progresses northward in that flow. And so by the time the game starts, whatever's driving this somewhat organized region of light precipitation is going to have made itself known here in Madison. So it'll be a light, rainy, relatively warm afternoon, and the heavier rain will be well to the northwest associated with the storm that's only slowly developing. So I'm not sure. This is in a region of really strong southwesterly, actually south-southwesterly geostrophic flow. There might be a little bit of barytonicity there. Let's go to 850 and just see if that's not the case. No, not really. On the southern end, there's a little bit, but not really on the northern end. So this is just warm, strong, warm, moist advection, and along that path, and no particular warm advection along the flow either, and maybe a little bit to the south. That can help to explain some of the structure of the precipitation that's in the forecast model. But it's not really robust. It doesn't knock your socks off. And the forecasted amount is light. So it could be hit or miss, but I bet you we'll get a little bit of a shower during the afternoon.
The SPC has us kind of on the edge of something maybe for thunderstorms tomorrow.
So a moderate risk.
No, it's not even a moderate. It's just a very slight.
I wish it was moderate risk.
Oh, yeah, so what if they color in this
Go
green?
tomorrow. You gotta get tomorrow's out. Yeah. Yeah,
Okay, marginal. So what's the green? Just
General
thunderstorm, okay, widespread thunderstorm. So the chance of a thunderstorm and maybe a marginal risk of something a little bit more than a thunderstorm. So that's,
Weather service has to be careful, right? After.
Yeah, that's true. But this is interesting. This is really not an obviously well-forced region by synoptic scale dynamics. There might be some other things going on that I'm not noting, but that's kind of interesting. So, and then the one up there in Minnesota isn't unforced. That seems like it is forced. Okay, let's go 12 hours further ahead. So we'll get to well, when everybody's having fun after the game, by midnight Saturday, the upper vorticity maxima is over the Lake of the Woods, so the cyclone's going to be in central Ontario, is my guess. There's a little bit more obvious jet feature indicated by the geopotential height gradient here, stretching from central Ontario down maybe to Sioux Falls. So that's going to only enhance the upper divergence in sort of central or west central Ontario. So I expect the cyclone center to be about right there. We may be finally feeling some frontal structure from this cyclone by this time, but I don't really have anything to base that on until I see the surface forecast. So let's see what it looks like. I think the thickness gradient will be a little more substantial over this by now. Yeah, so 992, and it's right in the right spot. So this has gone from 1,003 to 1,000, 997, 992. Slow but systematic development, precipitation fairly intense in certain locations around that storm. Here is the thickness gradient. If you can see it, yellow lines are every 60 meters, and the warm edge of that thickness gradient is right about over us, and it's actually, no doubt, being acted upon frontogenetically. So I think the later the day goes on in Saturday, the more well-forced the precipitation is going to be. So maybe some of that slight risk is actually accounting for the frontogenetic activity later in the afternoon. I wouldn't be surprised. It'd be fun to, time's running short, it'd be fun to look at some soundings and just see what the stratification's like. We know what it's felt like in the boundary layer for the last 2 weeks, tropical. And so one might easily imagine that the whole stratification has a tropical flair to it, which is about moist neutral. If you can get anything going, it's going to be freely convective somewhere in that column. And so a few spots will be the beneficiaries of some of that combination of circumstances.
The NMS model is showing something right over Madison at about 20Z tomorrow.
20Z Saturday.
Yeah.
Okay. A local time or?
20 UTC. So,
Oh, okay.
yeah, about what time is the game?
12, I think it's.
Game is at 11.
Oh, 11.
11, yeah.
Yeah.
It'll be over by 12, sorry.
That'll be
Well,
really quick.
it's showing thunderstorms and a maximum precip maybe just to the south toward Beloit, but
Oh, I like that. Okay. We'll see.
we'll see. Yeah.
I see the forcing coming in later. I don't see it early. So, but I don't know.
You can pull that up, or I can go back to.
You could, yeah, whatever.
Yeah, let's go forward and we can back to that.
We don't.
Let's go 12 hours more and that would get us to, where were we?
We're at 42.
Okay, so 54. So this will get us, I wonder why this happens.
Because WXP, the software that I'm using to draw these maps, is like 25 years old.
Oh,
I'm recasting all this stuff in Python, and one of these days we'll have the debut of that, but it's not quite there yet.
all right, we're not going to look at this because it doesn't say anything. So let's go to 73 hours again. Okay, that's better. So this is 21Z Sunday, which is what? It's
21 is 4 p.m.
4 in the afternoon. Yeah. So here's the upper trough. This is the one that was associated with the cyclone we've been tracing, and then there's a secondary curvature maxima at the base of this kind of broad, saggy trough. So maybe this will be just an opportunity to replenish the forcing for precipitation over us during the day Sunday, it looks like. And this is probably where our cyclone will be right at the mouth of James Bay. I'm not prepared to say it's going to be much deeper, but maybe a little bit deeper than 992. So let's say 990. Let's make a guess. See what it looks like. Yeah, no, 983 is there, and then this is 988, 992, so it's 994. It's beginning to fill in. There's the secondary slug of precipitation that might be tied to the piece of the trough structure that's hanging back to the south. So it's definitely interesting that something's going to happen beyond just a light rain over the weekend. The precise time at which that happens and the precise location is not exactly easy to tell. And as we can see, there are several different solutions to that already. But it does look like a rainy day Saturday, progressively rainier, I think, as the day goes on. And then probably we don't get out of the woods during the day Sunday, which is too bad. This is a lot of events going on Sunday afternoon that would benefit from nicer weather, but that's not going to be the case, I don't think, as we move into the weekend. And the other thing about it is that it's not really going to get chillier. You're not going to feel autumnal when it's raining. It's going to be warm and muggy. Probably will only add to the humidity on the following day. It's just going to be a struggle to get cooler. In fact, can we look at 850 at this time, Pete? One of the things I remember Professor Moore telling me when I was at undergrad at St. Louis U, was the 0-degree isotherm at 850 is where fall resides. And it's nowhere near the continental United States. So 0 is right here. In fact, it's this deeper aqua blue. So it's over western Hudson Bay. Churchill, Manitoba is 0 at 850 on Sunday afternoon. And it's way up in central Canada. So nowhere in the US is going to feel fall by that very colloquial but geeky definition.
Do we have any better chances during cyclone workshop for things in the other side of things?
Earlier this week, it looked like it. Let's take a look, Pete. Could we go to like, how far out do we have to go? We gotta go about maybe 10 days? That'd be midweek, next week at 8:50. We need the hemisphere. Let's try like 10 days at 8:50. Yeah, this will be Monday, so we'll just be getting underway, and we'll be in Germany, in southern Germany, Bavaria. So we'll be down in here, and so, yeah, look at fall's a little bit closer. Fall is south of Hamburg. So, and then let's go, yeah, Kelton, I'm with you. I want to see that. Let's go a couple days beyond that, 12 days out. Oh, yeah, very different situation. So there's France, there's Germany, Austria. So, yeah, it's much cooler. Yeah, that's really nice. So it'll be a little bit cooler here, but not anything like Germany.
Snow-capped mountains?
Huh?
Snow-capped mountains?
Maybe. Look to the south, that's where the Alps are, right? Salzburg and Munich are separated by not very much.
I think they're pretty far away, but.
Yeah, okay. So that's gonna be pretty nice. That will inform clothing choices, I think. So that's great.
Looks like
that's all.
something's coming in here too.
Yeah, well, I'll tell you, that in the long term, the Western Hemisphere is the center of cold air, but it stays forward of the border all the way through 16 days. But it does mass up over Canada. So
how much of that is also just the GFS bias? Because last week we were looking at this coming Friday, and we were saying we're going to be 30s. Like it was doing the same thing. It was bringing down cold air out of the.
yeah, I don't remember that.
I'm not sure if that's a model bias or something that's having to struggle with in terms of blocking ridging, but it seems at the end of the period in no man's land, it likes to bring the cold air down. That's just not happening.
Oh, that's interesting. I didn't notice that. Yeah, that's very interesting. So I'll have to keep our eye on that in the early, but maybe it's seasonal too. If such a bias exists, I bet it goes away when there's snow on the ground. Then it's hard to make up the fact that it's cold. It really is cold. But I don't know. That's really interesting. So that's what I have for the discussion today. And thanks you, Greg, for your contribution. Pete, thanks for driving, and everybody for coming and asking questions. And we'll see you next week, just before we head off to cooler climes in Central Europe.
Thanks.
Yeah.
There'll be cooler climes here too.
Yeah, it doesn't look like it. The week we're gone, it's going to rain every day.
I gotta worry about it because I gotta bring the cover.
Oh, yeah.
I think the flight's at 6 or 7 p.m. from Chicago, so I don't know if I will probably be.
Okay.
Okay, we'll meet with the 141.
Friday.
Let's take a 10-minute break.
Get in
Order
Saturday, and then take the train down. Sunday.